Hi there, this is Dr. Embody to talk about Project 4. And in Project 4, we're going to be actually working with functions. We have two functions that you have to create. In the skeleton code we give you the outline of the function. And whenever we have functions, you have to be very precise about what the inputs and outputs are of the function. And you want a function to just do something relatively small. So maybe you end up with lots of functions. But in this case, we've created a project that only needs two functions. Give us a start. And what we're going to do is build what's known as a finite state machine. This is it's a pretty simple yet very powerful way of handling, for example, an input very precisely. It is used by a lot of engineers and even outside of engineering. A classic example might be collaboration between computer engineers and mechanical engineers to control brakes. And you have certain types of inputs. You want to account for all the possible inputs, and you want to do specific things. And you can build a device that can handle something with precision, and you actually know that you've taken care of all the possibilities, which is very important in, say, something like putting brakes together. And in this case, we're going to do something much simpler than that, which is just recognize whether whoever is typing the input is laughing. So sort of a ha ha ho ho kind of a thing. And so we're looking for particular arrangements of characters. And a finite state machine works very nicely for that. So let's take a look at sort of the three pieces of this. So we're going to recognize what we're talking about, laughing, ha 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 ho ho ho, right? This type of thing, and some combination of those is what we are what we're after recognizing. And to do that, we use this thing that's called a finite state machine. And let me just hold off on going through that by looking at one of the examples. And so we have a little bit of a little header stuff there, instructions and so on, and then we enter characters one at a time. And when we just enter nothing, that is just hit the carriage return, that's when we stop and evaluate whether what has been entered. In this case, it's ha, and that is something that we label as being laughing, and so on. And there's various combinations. So like the next one is has a ha, a ho, a ha, and then an exclamation point, and then nothing, and so we go ha ho ha, right? And again we say, yep, you're laughing. So how does the finite state machine actually help us with this? And what I'm going to do is put this right next to put the samples right next to the finite state machine. Now the way the machine works is that it has a start point, that's state that we're calling number 1, and it has endpoints that are either success or failure. And so in our case, if it's success, we say you're laughing. If it's not, then we say you're not laughing. And to move from one state to another, there is this transition is done based upon a character. So in this case, an H character will take us from state 1 to state 2. All the other characters will take us here, because if it doesn't start with an H, then we're not laughing. So in this case, the first input is an H. We recognize that here, and we now move to state 2 because we have seen an H. The next one is an A, and if the input is an A or a 0, we move to the next state 3, and any other character would take us down here to the failure. And one of the things you'll notice is when you're in state 5, all characters will keep you in state 5. So if you started off with an X, for example, you could have all the ha's and ho's that you wanted. Doesn't matter, because you didn't start with an H. Therefore, whatever you do, you're going to end up not having been you're going to end up in the failure mode, which we're calling not laughing. All right, so we're in state 3 because we've done an H and an A, and now we have an exclamation point. That takes us to state 4, and that's successful. We end right there. So we're in this state 4. We entered the ha, and we say we're laughing. Let's do another one. Test 2. We'll go through the same process. We always start here in state 1. And we type an H. Okay, so we're good. We're going into state 2. Then we type an A. That's all right. That takes us into state 3. Then we type another H. All right, so that's this H. That takes us back to state 2. Now we're in state 2, and we have an O. Okay, so we have an A or an O, and that puts us into state 3. Then we have another H. Okay, so we're going around again, back into state 2. Then we have an A. That's also good. That takes us into state 3. And then we have an exclamation point. That guy, that takes us into state 4. Then we end, and we see we have ha, ho, ha, and we say we're laughing. Okay, so those are all good states. Let's do one that is that fails. All right, in this case, we type more than one character. It says that's invalid input. We only want one character at a time. So you have to make sure you have that error condition there. Here we type an A. All right, and so that's our first character. So that's not an H. We always start here. We had something other than an H. All other characters take me here. Oops. Take me here to the failure state, and then I stopped. We entered an A. We're not laughing because we're in the failure state. All right, let's do another one. Let's do number 4. Okay, so we always start here. So we've done an H, so that takes us into state 2. We have an A, that takes us into state 3. We have an exclamation point, that takes us into state 4. We have another A, all other characters, that puts us into the, and then we stop. So we have a ha followed by an A. We're not laughing. Okay, and there's we can keep going through these cases. Test case 5, for example. Again, we always start here. So we do an H. We do an A. We're looking good, but then we stopped. So we have a ha, but no exclamation point. So we are not laughing at that point. And then there's another one that the final example here. Okay, we start with an H, that gets us to 2. We do an A, that gets us to 3. We do another H, that gets us back to 2. And now we do an E, that takes us, because we're in state 2, we got something other than an A or an O. That puts us into the failure. Any other character here keeps us in the failure, and it doesn't matter, even though that's all other characters, including, because we're in here, all other characters keep us in that state 5. So we had ha, he, and by our definition, we're not laughing. Now, we specify that you have to have a couple of functions. and these are required, and they are in the sample code that we give you. And the first one is the get character. It doesn't take any parameters. Nothing is coming into it. It also doesn't ask for any input. So we can't have the input in here. It prompts for a character, and I guess this is confusing. I think we need to rewrite that. It doesn't take any arguments. I think we has no arguments. So it's going to prompt for a character and return it if it's an empty string or a single character. It will print an error message and reprompt. That means you have a loop. Okay, and we don't know how many times it's going to loop, so that means it's going to be a while loop. And it reprompts if the input length is more than one. All right, so if you put more than one character in there, it's going to say, do an error message, and it will keep asking that until you enter a single character or an empty string. So you have two conditions here that you have to watch out for. So I'm going to fix this about inputs, because that's so this function takes two arguments, right? And so it has two parameters. Hopefully that'll be fixed by the time you're reading this. It has the current state that you're in, and it has the input character, and it finds the next state and returns it. And that is, let me show you here, what this function is doing is, when you're in some state, such as state 3, okay, that's what we mean by the state. So we might be in state 3. And now we send a character. Suppose we sent the H character. Then what this function would return, it would say, oh, you are now in state 2. It would return the state 2. So you started in 3, you put an H, and you wanted to 2. Maybe if you started in 3 and you did any other character, then you'd return a 5. So this is finding the next state. And you can see we give you a we give you a code outline there, and you want to use that. You don't. One of the things that we don't allow you to do is you have to use this name. You have to use the correct number of arguments, number of parameters. No parameters there. These two parameters here in that order, the state first and the particular character second. And notice that each one of these functions has a small task. This just gets our character. All right. This one, when we're in some state, it tells us, based upon that character, what the next state will be. We do help you out by, when you're writing this, when you're writing the find state function, that is, when we're doing this function, we try to help you out here by saying this is going to be a bunch of if and maybe elif statements. So if we're in some state X, if the character equals Z or character equals W, then the next state will be that one. Otherwise, the next state will be the other one. And then at the end, you will return the state. Or, since we know we're just returning one state, in this case here, I could just say return A. And then here, instead of saying state and then return, I could just do the return right here. Either way, that's a design decision. I happen to like this because we know all we're doing is getting the state, and then we're done with the function. It's like, okay, return this one. And there are some nice things about you can actually reduce the number of ELIF statements that you have with that, and maybe make it easier to read. All how you think about it. All right, so there's there's some things about the project. Good luck.